So we'll get started with homework question 14. They ask for the pH of the buffer, and let's see who asked the question. So Rebecca, they're asking for pH of a buffer, and we're mixing 30 milliliters of HF. And Rebecca, could you tell me the concentration of HF from your question and the concentration of potassium fluoride as well?
HF is 1.3 and then the other is 2.2.
So these are variables in the question. That's why I asked. So just be careful. The steps will be the same, but your numbers will be a little bit different. So we've got a buffer. We've got a weak acid and its conjugate base. So HF, right, is a weak acid. Potassium fluoride is the conjugate base of that. Right, so we've got a Henderson-Hasselbalch problem, right? pH equals pKa plus the log of my base over the concentration of my acid. And they give us one more thing, right? They tell us that the Ka is 7.2 times 10 to the minus 4 for HF. So first, we have to do one thing. We have to mix these two together. So I mix these two together and I get a new volume of 50 milliliters. So because I'm mixing these two together and my volume is changing, my concentration changes as well. So we need to find our concentration for HF, our new concentration for HF, and our new concentration for potassium fluoride. And we do that with M1V1 equals M2V2. So for HF, my initial concentration was 1.3 with an initial volume of 30 milliliters. And I want to find my new concentration when I have a volume of 50 milliliters. And for potassium fluoride, I'm going to do the same thing. I've got an initial concentration of 2.2. When I have 20 milliliters of that, I'm looking for what's my concentration when I mix the two together and my final volume is 50 milliliters. So we'll do both those calculations. So 1.3 times 30 and then divide that by 50. I get a concentration of HF of 0.78 molar. Do the same thing for potassium fluoride, 2.2 times 20 and then divide that by 50. I get a concentration of potassium fluoride of about 0.88 molar. Now we can use the Henderson-Hasselbalch equation because now we have the concentration. Once we mix those two solutions together, we have the concentration of both my acid and its conjugate base. So the Henderson-Hasselbalch equation, pH equals pKa means the negative log of Ka, so negative log of 7.2 times 10 to the minus 4 plus the log of my base. My base is the potassium fluoride, so 0.88 over the concentration of my acid, 0.78. So pH equals, so negative log of 7.2 times 10 to the minus 4 plus the log of 0.88 divided by 0.78. And I get a pH of 3.195, which I would round up to a pH of approximately 3.20 for this question. Right, so we knew it was a buffer question. We knew it was Henderson-Hasselbalch because we had two things. We have a weak acid present and its conjugate base. Before we could find the pH, we also had to find our new concentration because we mixed together 30 milliliters of the acid, 20 milliliters of the conjugate base, and then we can use the Henderson-Hasselbalch equation to find the pH after that.